Hello, everybody. Welcome to the Construction Record Podcast. I'm digital media editor Warren Frey, and with me today I have
Kevin Weiker, Engineering Director for Capital Projects with the BC Ministry of Transportation and Infrastructure.
And as everyone knows, just about a year ago, as of, I guess, next month, we had massive floods in BC that did substantial damage to a lot of infrastructure. And Kevin recently at the Canadian Institute of Steel Construction gave a presentation about what the immediate response was in terms of infrastructure and mitigation and what the ongoing repair was and what they're doing going forward. So that's what we're going to talk about today. So I guess what I would start with is maybe you could describe the immediate flood damage to some of the infrastructure and the main causes of the damage. Because in the presentation, you said there were like 2 or 3 big ones that caused all the subsequent damage.
Yeah, for sure. There was really widespread damage and a lot of different types of damage to a number of our highways and quite a significant amount of our highway infrastructure. All of the highways really that connected Vancouver and the Lower Mainland to the interior and of BC and to the rest of Canada were impacted in a number of different ways. And really, the damage was all caused by the atmospheric river event that hit the region, dumped approximately a month's worth of rain onto the mountains in about 2 days' time, caused a lot of the smaller creeks that normally have very little water in them to turn into raging torrents. And they did a lot of damage to our infrastructure. Really, the damage could be categorized into 5 different types. We had several locations, especially on Highway 5, the Coquihalla, where the scour from the river actually caused bridges to collapse. Full bridge spans collapsed into the river. We had several locations on a number of the different routes where the highway was washed out. Just the erosion of the embankments took out multiple lanes of the highway at several different locations. The third type of damage, which we saw also on all the highways, was mudslides and debris flows. In some locations, we had the highway buried upwards of 10 meters of mud on the highway. And we also had several locations where we had culverts that blew out. Some of the places, the culverts had a bit of damage, some corrosion to them ahead of time. And just with the volume of water that came down, they just completely failed. And the final type of damage that we saw, and it was fairly widespread, seen lots of pictures on the news as the event happened, was the major flooding that happened on Highway 1 in the Fraser Valley. Just a pure volume of water submerged the highway.
What was the response in terms of repair and construction? I know in the presentation you said a few teams were basically, as the damage was ongoing, people were in there trying to mitigate it. It was that quick that people were on the job, basically trying to fix things.
Yeah, actually, the work that was happening during the event was trying to prevent it from being worse than it was. I mentioned on the Highway 5, we had a few bridges that collapsed. We also had our district operations folks and some of our maintenance contractors out there during the storm doing what they could to protect a couple other bridges that were on the verge of collapsing. And we're in a situation that if nothing was done, the rivers would have continued to scour and we would have lost at least one more bridge, potentially 2. But we had the maintenance contractor out there during the event with their excavators, putting rock in front of the bridges, trying to do whatever they could do to protect the abutment and to minimize the scour. And they were successful in that. We managed, they managed to save that bridge. So it was standing. We had to go in and do some repair work afterwards. But they were out there right in the thick of the storm, preventing further damage from happening.
And what role did steel play in building temporary bridges? Not just steel, what other materials do you use in the temporary bridges that you wouldn't, obviously with a permanent structure, it's going to be differently built, but what did you use to get this done quickly, but still reliably?
Yeah, really two different approaches were taken to the temporary bridges, depending on where they were located and what the type of failure was. The ones where we had the full collapses on Highway 5, those were multi-span bridges, 3-span bridges, and what we lost were the end spans. So rather than trying to rebuild those spans for a temporary configuration, what we actually decided to do was fill in that span and build an MSE wall right next to the pier, within about a meter or 2 of the pier. and then used a short precast concrete slab to span from the MSE wall onto the pier and onto the rest of the bridge that was still standing. And that was done simply due to time constraints. There was a lot of pressure to get Highway 5 opened up as quickly as we could. And the bridge collapses, fixing those was on the critical path. And that was the fastest way that we could come up with to repair those locations, get highway traffic moving again. And it was also feasible to do because once the river water went down, we were actually working in the dry up to the pier. A couple other locations particularly on Highway 8 and also Highway 1 in the Fraser Canyon, we were not able to do a similar type of repair. And we actually needed to install some fairly long bridges. And that's where the structural steel bridges really, really shone through. Two of them on Highway 8 were done with steel girders, so 2 parallel steel girders. For those ones, we actually used wood decks. Again, trying to get materials as quickly as possible. But 2 locations. One of them was a single span bridge that was launched across with a launching nose. Another location on Highway 8 used it was actually a 2-span bridge. We were able to get out into the middle of the river and build a temporary pier and launch that bridge also. So those were done that they could get to be fairly long spans, and they were installed quite quickly. And one other location we used a steel bridge, not a conventional girder bridge, but actually an acro truss bridge, was on Highway 1 down in the Fraser Canyon. At Falls Creek near the Jackass Mountain summit. There was a big embankment with a culvert under it that got completely blown out during the event. We ended up with a big hole that was about 80 meters wide. And the solution there was to install an acro bridge. So the engineers worked quite closely with Acro Canada and came up with the design for the bridge and the launching scheme. And they were able to get that put into place quite quickly. Single lane acro, and it allowed us to really fill in that one critical piece of infrastructure to get Highway 1 open again.
Now, I might be talking about the same bridge here, but there was in your presentation, you're talking about this one bridge where you couldn't really disturb the surrounding area, presumably for environmental reasons, or just because it was unstable. So you had sort of extending steel that went from one end to the other, just sort of like in a series of nodes. And maybe you could explain, I think this is at Spence's Bridge. Maybe if this rings any bells, you could explain that one.
Yeah, that was one of the bridges on Highway 8, the structural steel girder bridges that were installed there. Again, we were going over the river, and the river is an environmentally sensitive area. So they were, we were using the structural steel to be able to get a fairly long span and a fairly wide opening under the bridge to allow the river to pass under the bridge and stay out of those environmentally sensitive areas.
And so a year later, almost, where do we stand in terms of recovery and ongoing construction?
Yeah, there's been a lot happen in the past year. Several of the routes that were impacted by the event, Highway 1 in the Fraser Valley, Highway 3, Highway 7, Highway 99, all of the repairs are complete on those routes, and they are back to functioning the way they were before the event. Highway 8 is still in what the ministry calls response mode, which is basically the work that needs to be done to get the highway open up to the public again. Highway 8 was probably the most significantly impacted highway in the event, where we lost literally kilometers of the highway was just washed away into the river. So there's been a lot of work ongoing on that route just to reestablish access. And we're at the point now where it is actually possible to drive from one end to the other on Highway 8 now. The highway is still closed to the public, but there is access for construction vehicles so they can fully access the route to be able to complete the necessary repairs to get it open to the public. And also, it is open on a limited basis to some of the residents who hadn't been able to get back to their properties since the event in November. They were completely isolated. So that's been a big step forward. Work is ongoing there to get the road up to a state where it will be open again to the public. looking very different than it did before the event. Lots of single lane sections and gravel sections, but that work is ongoing. The two bigger highways, Highway 1 through the Fraser Canyon and Highway 5, the repairs there are both being delivered through alliance models, which is essentially a type of delivery where the builder, the designer, and the ministry are all together on one team to deliver the project. The Highway 5 work was awarded back at the beginning of the summer, and they've been working all through the summer. Building temporary bridges and building some permanent bridges. The intention on Highway 5 is to have the Coquihalla Freeway back up to 4 lanes and of operation before the end of this year. Some of that will be on some temporary structures as they're building the permanent structures, with the intention of having all the permanent works to be done by the end of next year. And on Highway 1, the successful contractors and designers were just awarded about a week and a half ago. There was a press release that went out with that. So 3 separate alliance teams for the 3 different project sites along Highway 1. So that work is really just getting ramped up, and it'll be in full swing next year.
Okay, and finally, I know these things were originally built for a world that's much different than the one we're in now. Yeah. So in terms of climate change, in terms of what you guys have learned from the floods and what materials you think should be used, what do you think in resilience, what do you think is going to be the sort of the path going forward in general terms for that?
Yeah, that's a really interesting point. I think the biggest thing that the ministry and I think the industry in general is learning is just that climate change is real and the impacts of it are very real and very profound. The ministry has been designing all of our new infrastructure to accommodate the impacts of climate change for the past probably 7 or 8 years now. We've had a technical circular issued giving some guidance to our designers for how to implement and design for climate change. And events like this just really bring that to the forefront about how important it is to continue to design for climate change and really get a better understanding of what the future impacts of climate change could be. So our ministry is working very closely with industry and with some academic research institutes to really stay on top of that and to be at the forefront of developing these new climate prediction models and ensuring that what we design and what we build going forward is not going to be susceptible to these events. So when these events happen in the future, because I think everybody is quite certain that they are going to continue, and when they do happen, we're designing our infrastructure so that they won't be impacted by these events, and that the infrastructure that we build will be able to survive these events and continue to provide the service that it needs to provide.
Thanks very much for joining us today.
Thank you.